Okay, so welcome back to video 2 of the lecture series on logic gates. In the previous video, I taught you what logic gates are and how to draw the truth table. Now I'm going to introduce you the logic gates themselves. All right, so these are the logic gates that I'll be teaching you in your syllabus. You have your NOT gate, your AND gate, your OR gate, NAND gate, and NOR gate. So remember, these devices help you make decisions. Yeah. So there are many decisions in our lives that we have to take, and depending on the situation, we can choose which gate to help us make those decisions. All right. So for a start, I'm going to be talking about zeros and ones. Then later on, subsequently, I'll teach you how to connect the zeros and ones to the scenarios and different situations in life. Okay, so the first gate that I want to teach you is something called a NOT gate. Yeah, so a NOT gate is one that gives you the output that is not the input. So for example, if I put in a 0, a NOT of a 0 is a 1. Okay, so it takes the 0, it changes it to a 1 for you. But if you put a, let me change to a different color. If you put a 1, it will give you the opposite. It will give you a 0. Okay? And we can represent this in a Boolean expression. Think of a Boolean expression as something like an algebraic equation. Okay, so it's written here algebraic function, but in my class, I will call it a Boolean expression. Okay? So a Boolean expression for a NOT gate is the output bar the input. Okay, so this bar here tells me that the output is going to be the opposite from the input. Okay, and this is the truth table of a NOT gate. So the input is 0, 1, and the output, in this case, is F. It can be any alphabet, it can be X, Z, Y, W, up to you. In this case, it just happens to be F. So the output is the opposite of the input. So if I put in a 0, it'll give me a 1. So if I put in a 0, it'll give me a 1. If I put in a 1, it'll give me a 0. It's just the opposite. Okay? So this is a NOT gate. The next gate that I want to talk about is a AND gate. And I think you can surmise from now, the two inputs must be something and something. All right, so it will only, so this is how an AND gate works. It will only give me a high output. It will only give me a high output if input 1 and input 2 are high, and only if input A and input B is high, then it'll give me a high output. Okay, you can see this in the truth table over here. If both inputs are high, then the output will be high. Everything else will give me a low. So both inputs need to be a high. If one of the outputs, one of the inputs is a low, if one of the inputs is a low, then the output will be a low. Okay, so both inputs need to be high. Input A and input B high, then it'll give me a high output. Otherwise, so long as one of the inputs is a low, it'll give me a output low. And the Boolean expression is a dot. So if I want to say A and B, I have to write A dot B. The dot stands for N. Okay, so let me highlight this for you. Okay, so if I want to represent N, it's a dot. So A and B. Okay, so this is an AND gate. Next, let me go on to a OR gate. An OR gate, the name itself tells you that so long as either one of the inputs is a high, the output will be a high. So if I have A or B being a high, the output will be a high. Okay, So if A or B, so in this case, A is high, since it's an OR, the output will be a high, or vice versa. If I don't want A to be high, I can have B to be high and A to be low. It's still an OR, right? B or A is high, the output will be a high. The only time that it gives me a low is when both inputs are low. So if both inputs are low, none of them is a high, right? So if both inputs are low, the output will be a low. So remember this truth table, okay? You have to remember the truth table for your not or and. So if you look here, back to the or, 0, 0, none of them is a high, so the output will be a low, 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 output low. Low, high. Now remember it's a or, so either A or B is a high, the output will be a high. A or B is a high, so output will be a high. Okay, and the Boolean expression for or is a plus sign. So when you see A plus B, I know it's slightly confusing, you just have to get used to the symbols here. It means A or B. Okay, so when you see a plus, remember it stands for or. You have to remember or. When you see a dash on top, it stands for a not. It's the opposite. If you see a dot, it stands for and. So A and B, A or B, A is not the input. Okay? Now there is two other gates that I would like to teach you. It's called a NAND gate. A NAND stands for, the N stands for not and. It is not and. And it is differentiated from an and by having a dot at the tip of the AND gate. So this is an and this is a not. So a not is the opposite of a AND. So if you look here at an AND gate, 0, 0 is 0. If you look at a not and 0, 0 gives a 1. It's the opposite. 0, 1 gives a 0. 0, 1 gives a 1. It is not and. 1, 0 gives, 1, 0 gives a 0, but the not and gives a 1. A 1, 1 for an and gives a 1. Not and gives a 0. So it's the direct opposite. So if you have been following and understanding the symbols, F equals to A and B, and the bar across means not. Okay, so this is the Boolean expression for NAND. And the last gate that I'm going to teach you is a NOR gate. So this NOR stands for not or, not or. So a NOR, if you look here, 0, 0 gives a 1. In this case, not or, 0, 0 gives a 1. It's the direct opposite. This for a OR gate, the output is 0, 1, 1, 1. The output for NOR is 1, 0, 0, 0. So it's the opposite here. And the Boolean expression that you need to remember, A or B, not. Okay? So I hope I've explained what these gates are, and I hope I've also explained how you get the truth tables for all these 5 gates that you have to know and remember. Okay, so summary, know how to draw these gates. You need to know how to draw these gates. You need to know the names. You need to remember the names. You need to know the Boolean expression, and you need to remember by heart the truth table. Okay, Ken? So I think this is a pretty good summary page for the info you need. Look through this. If you want to, you can practice drawing the symbols. If you're not sure whether you're getting the drawings right, show it to me. I can give you my feedback. Remember all the truth tables by heart. You shouldn't have to think about it. Remember the input patterns and know what are the outputs for the different gates. Okay, so I'm going to stop the video here. Look through this video if you need to again to understand, and you can look through the textbook to help you further solidify your learning. If you have any questions, same thing, you can email me or you can see me in school. I will see you in video 3 soon.